The XR-101 Dark Falcon is a name that sparks imagination the moment it is spoken. It sounds like something pulled straight from the future, a machine designed not only to dominate the skies but to redefine what air combat means in the modern era. While the XR-101 Dark Falcon is a conceptual aircraft rather than an officially recognized military platform, it represents the next step in the evolution of American aerospace engineering. Imagine a fighter jet so advanced that it combines artificial intelligence, unmatched stealth technology, hypersonic speed, and battlefield awareness into a single platform capable of changing the outcome of any conflict before the enemy even realizes it has arrived. The story of the XR-101 Dark Falcon begins with a vision. For decades, military planners and aerospace engineers have sought to create the ultimate air superiority fighter. Every generation of aircraft brought new capabilities. From the legendary fighters of World War II to the advanced stealth aircraft of today, each step forward was driven by the need to gain an advantage in speed, maneuverability, firepower, and survivability. The Dark Falcon was conceived as the aircraft that would combine all of these qualities while adding technologies that previous generations could only dream about. At first glance, the aircraft appears almost alien. Its sleek black exterior absorbs light, giving it a mysterious and intimidating presence. Sharp angles blend seamlessly into curved surfaces designed to reduce radar reflections from every direction. The aircraft's wings are integrated into the body through a blended design that improves aerodynamic efficiency while maintaining stealth characteristics. Every aspect of the jet's shape serves a purpose. Nothing is added for appearance alone. Every line, every curve, and every surface contributes to performance. One of the most impressive aspects of the XR-101 Dark Falcon is its stealth capability. Traditional stealth aircraft rely primarily on special shapes and radar-absorbing materials to reduce their radar signature. The Dark Falcon takes this concept to an entirely new level. Advanced adaptive skin technology allows portions of the aircraft's surface to alter their electromagnetic properties in real time. This means the aircraft can actively adjust itself to minimize detection by different radar frequencies. Combined with next-generation radar-absorbing composites, the result is an aircraft that becomes exceptionally difficult to detect, track, or target. Speed has always been a critical factor in air combat, and the Dark Falcon is designed to excel in this area. Powered by twin adaptive cycle engines, the aircraft can seamlessly switch between fuel-efficient cruising and maximum thrust combat modes. These engines provide extraordinary performance across a wide range of flight conditions. In combat configuration, the XR-101 can reportedly reach speeds exceeding Mach 3.2, placing it among the fastest fighter aircraft concepts ever envisioned. Such speed allows it to rapidly respond to threats, intercept enemy aircraft, and escape dangerous situations before opponents can react. Yet raw speed alone does not guarantee victory. Modern warfare increasingly depends on information, and the Dark Falcon is designed to dominate the battlefield through superior situational awareness. Its sensor suite integrates data from multiple sources including radar, infrared tracking systems, electronic intelligence sensors, satellite networks, and unmanned support aircraft. Artificial intelligence processes this massive flow of information in real time, presenting pilots with a clear and simplified picture of the battlefield. Instead of being overwhelmed by data, pilots can focus on making critical decisions while the aircraft handles much of the information management automatically. The cockpit itself represents a dramatic departure from traditional fighter designs. Large panoramic displays replace conventional instrument panels. Advanced augmented reality systems project vital information directly onto the pilot's visor. Threats, targets, navigation points, and mission updates appear seamlessly within the pilot's field of view. Voice commands and gesture controls allow rapid interaction with onboard systems. The goal is simple: reduce pilot workload while increasing combat effectiveness. Perhaps the most revolutionary feature of the XR-101 Dark Falcon is its integration of artificial intelligence. Unlike traditional autopilot systems, the aircraft's AI functions as a true digital co-pilot. It continuously monitors aircraft performance, mission objectives, environmental conditions, and potential threats. The AI can suggest tactical maneuvers, identify high-priority targets, manage electronic warfare systems, and coordinate with friendly forces. In emergencies, it can even assume temporary control of the aircraft to help protect the pilot and complete mission objectives. Weapons technology aboard the Dark Falcon reflects the changing nature of modern warfare. Internal weapon bays preserve stealth characteristics while housing an impressive array of munitions. Advanced air-to-air missiles provide long-range engagement capability against enemy aircraft. Hypersonic strike weapons enable rapid attacks against high-value ground targets. Precision-guided munitions offer flexibility across a variety of mission profiles. Directed energy systems, including high-energy lasers, add an entirely new dimension to combat capability. These weapons can potentially disable enemy sensors, intercept incoming missiles, or damage aircraft systems at the speed of light. Electronic warfare has become increasingly important in modern conflicts, and the Dark Falcon is designed to excel in this environment. Powerful electronic attack systems can disrupt enemy communications, jam radar networks, and interfere with targeting systems. Advanced cyber warfare capabilities may even allow the aircraft to infiltrate digital networks and manipulate battlefield information. By combining kinetic and non-kinetic effects, the XR-101 becomes more than just a fighter aircraft. It becomes a mobile command and control platform capable of influencing every aspect of the battlespace. The aircraft's survivability extends far beyond stealth. Advanced defensive systems continuously monitor for threats from all directions. Missile warning sensors provide immediate alerts when hostile weapons are launched. Automated countermeasure systems deploy flares, chaff, and electronic decoys as needed. Directed infrared countermeasures can interfere with heat-seeking missiles. In extreme situations, autonomous defensive algorithms can initiate evasive maneuvers faster than any human pilot could react. One of the defining concepts behind the XR-101 Dark Falcon is manned-unmanned teaming. Future battlefields are expected to feature large numbers of autonomous systems working alongside human operators. The Dark Falcon serves as the command center for these networks. Pilots can control multiple drone wingmen simultaneously, assigning them tasks such as reconnaissance, electronic warfare, target designation, or direct attack missions. These unmanned systems extend the aircraft's reach while reducing risk to human personnel. Imagine a combat mission deep inside contested airspace. Long before entering the area, drone scouts move ahead of the Dark Falcon, collecting intelligence and identifying threats. Electronic warfare drones begin disrupting enemy radar systems. As the aircraft approaches, artificial intelligence analyzes incoming data and recommends optimal flight paths. Potential threats are highlighted instantly. Targets are prioritized automatically. The pilot remains fully informed while maintaining complete authority over mission decisions. As enemy defenses attempt to respond, they encounter a problem. Radar systems struggle to detect the stealth aircraft. Communication networks experience interference. Command centers receive conflicting information. Meanwhile, the Dark Falcon continues moving at extraordinary speed, positioning itself for maximum effectiveness. Hypersonic weapons launch from internal bays and reach their targets within minutes. Enemy air defense systems are neutralized before they can mount an effective response. Air-to-air combat scenarios highlight another advantage of the XR-101. Traditional dogfights may become increasingly rare as long-range sensors and missiles continue to improve. Nevertheless, the aircraft remains highly maneuverable thanks to advanced flight control systems and thrust vectoring technology. Artificial intelligence continuously calculates optimal maneuvers while monitoring enemy behavior. If visual range combat becomes necessary, the Dark Falcon possesses the agility and responsiveness needed to outperform most adversaries. Range and endurance also play important roles in modern military operations. The adaptive cycle engines significantly improve fuel efficiency during cruise flight, allowing the aircraft to cover vast distances without refueling. Combined with aerial refueling capability, the XR-101 can operate across entire regions while maintaining readiness for extended missions. This global reach aligns with the strategic requirements of modern military forces operating across multiple theaters simultaneously. Maintenance and logistics often receive less attention than speed or weapons, yet they remain essential for operational success. The Dark Falcon incorporates advanced diagnostic systems capable of monitoring thousands of components in real time. Predictive maintenance algorithms identify potential issues before they become serious problems. Ground crews receive detailed reports immediately upon aircraft landing, allowing repairs to be performed efficiently. This approach reduces downtime and increases mission availability. The materials used in constructing the aircraft represent another leap forward. Lightweight composite structures provide exceptional strength while minimizing weight. Nanotechnology-enhanced materials improve durability and resistance to environmental damage. Certain structural elements may even possess self-healing characteristics capable of repairing minor damage automatically. These innovations contribute to both performance and long-term reliability. Training pilots for such an advanced aircraft presents unique challenges. Traditional flight instruction must be supplemented with extensive simulator training focused on managing AI systems, autonomous drones, and complex information networks. Virtual reality environments allow pilots to experience realistic combat scenarios without leaving the ground. Continuous software updates ensure that training remains aligned with evolving operational capabilities. The strategic implications of an aircraft like the XR-101 Dark Falcon are enormous. Nations possessing such technology would enjoy significant advantages in deterrence and military effectiveness. Potential adversaries would need to invest heavily in countermeasures and next-generation defense systems. The presence of aircraft capable of penetrating sophisticated defenses while remaining difficult to detect could alter strategic calculations across entire regions. Beyond military applications, many of the technologies developed for the Dark Falcon could eventually influence civilian aerospace industries. Advances in materials science, propulsion systems, artificial intelligence, and energy management often find their way into commercial aviation over time. History has repeatedly shown that innovations originally developed for defense purposes can lead to broader technological progress benefiting society as a whole. As technology continues advancing, concepts once considered impossible gradually become reality. Stealth aircraft, satellite navigation, precision-guided weapons, and unmanned aerial vehicles all began as ambitious ideas before becoming operational systems. The XR-101 Dark Falcon represents the next stage in this tradition of innovation. It embodies the belief that future challenges require bold solutions and that technological superiority remains a decisive factor in maintaining security. The image of the Dark Falcon soaring through the upper atmosphere captures the imagination because it symbolizes more than just machinery. It represents human ingenuity, determination, and the relentless pursuit of excellence. Engineers push the limits of physics. Scientists develop new materials and technologies. Pilots train tirelessly to master increasingly sophisticated systems. Together, these efforts create capabilities that previous generations could scarcely imagine. Whether viewed as a glimpse into the future or as an ambitious conceptual design, the XR